Hi everyone, today I'm going to show you how to calculate the sample variance. I'm going to show you three ways, a hard way, an easy way, and a very easy way. For my demonstration, I'm going to show you how to do it for these list of 6 numbers here. Okay, first way. Here is the formula for the sample variance. Now let's just look at what this notation means. This here stands for summation, add up. Xi stands for the individual observations, where I is a counter from 1 to n. So the xi's are just labels of the numbers. So I could call this x1, this could be x2, x3, and so on. It doesn't matter how we label these numbers so long as each one of them is only labeled once. This is read as x bar, and x bar denotes the sample mean. Finally, we've got n, which appears here and here. N denotes the number of observations. Here we have got n is 6 because we've got 6 numbers. So first we have to calculate the sample mean, x bar. Well, x bar, the definition is that add up all the numbers and divide by the number of numbers we've added up. So we've got these numbers, divide by numbers we've added up, numbers of observations, which is 6, and what do we get? We get 328 in the numerator, denominator, sorry, it's not that. We get 40 over 6, which is equal to 6.66 reoccurring. Okay, to use the formula, it's easiest to see it as a table. So we've got the data running down here. Next we've got to complete these two columns. Xi minus x bar, that's saying for each observation subtract the sample mean. So when xi is 2, we've got xi is 2 minus x bar, which was 6.66 recurring. Next one, that is 5, so it'll be 5 minus 6.66 recurring, and so on till I've completed this column. Next, for the third column, I need to take each of these entries here and square. So this one would be 2 minus 6.66 recurring all squared. I get 21.77. Okay, and if I do it for each of these cells, I will get these numbers, which, well, you check it, I hope they're right. Finally, totting up these numbers in the column, we get about 61.435. Okay, so we've got everything necessary now to compute this sample variance. We need this number. So here is the formula again. What we've just calculated is the numerator. So that is 61.435 divided by n minus 1, that is 6 minus. I'm going to find that is 12.287. If we want, we can also get the standard deviation. Recall that the standard deviation is the positive value of the square root of the variance. So here we have square root of 12.287, it's approximately 3.51. Right, let's move on to the second way. The second way is to apply this formula, which is equivalent to the one we've just applied. Okay, now this reads sum of, take each value and square it. So what we have is first number squared plus second number squared plus third number squared all the way to the plus sixth number squared, that equals, or if you add them up, to 328. That gives us the sum of xi squared. Now the sample mean we've already calculated, it's 6.66 recurring. So entering these into the formula there, we have this. Note this term here is x bar squared, so we square the mean, sample mean. Okay, entering the numbers into the formula, in the numerator we're going to have 61.3387, the bottom part is 5, so the answer for the sample variance is 12.267, and the standard deviation will be 3.50. Now, having done that, which do you think is a quicker method? This first way, or the second way? Well, I think you can see that this second way is much neater. You can do the calculation much faster. And also the other thing is that notice, since we've got fewer calculations, we've got fewer decimal places, figures with decimal places. Sum of the xi squared, no decimals. Here we have just a decimal. Using the first way, notice that we've got decimals coming in, one for every line here. Now every time we're using a decimal, we're kind of approximating, so if we have more and more decimals, work with more and more decimals, then the errors will add up. For those reasons, I suggest that you use this second method. Now finally, I'm going to show you